for every account that's in the values, that's what the calligraphic V is, values of the accounts. So we're just looking at every service account. We have a few extra useful like causal terms, basically derivative terms, terms whose value is an equivalence with some pre-existing stuff. So AI, which is the number of keys, basically, in each of the dictionaries, is twice the number of keys in the lookup dictionary plus the number of keys in the state dictionary. That's just basically, we're keeping a track of how many keys we are storing in the service contract, in the service account. L is basically the amount of data that we're storing, and that's the sum over all of the keys in the lookup. We add this offset for each key, 81. That's basically how many bytes are required to store each item, plus the size of the item itself, Z. And then we do the same for the state. That's for the lookups. This is for the state. And it's 32, which is the size of the key. It's a hash, plus the size of the data. Yep. Now, we don't. This is something that needs to be sort of managed by the implementation, right? It's not something that we just have this equivalence here, which means we're being quite lazy in the maths. We're just saying, we assume the implementation knows how many entries there are and what their size is. Yeah, this is something that implementations have to actually manage on their own. We're not holding their hand. We assume that it is known. We define this equivalence A sub T, the balance threshold. This is basically the minimum balance, or the existential deposit in Polkadot terms. Minimum balance of a service account. And as you can see, this is defined as through adding these things up and multiplying them by some factors. And this is what gives us the deposit requirements for storing data on-chain. We basically just set the minimum balance, and then we require the actual balance to be greater than that minimum. And this should be somewhere. Did I miss it? I would have thought it would be in the invariants, but apparently not. Okay. Well, it is an invariant, even if it's not explicitly mentioned. Yeah, doesn't see it. It seems that it's not actually explicitly mentioned. So yeah, there is a second dependent term T, the threshold balance, and this must be greater than the actual balance. In fact, this is enforced later on when services attempt to store data or transfer balance out. So if you jump to the appendix, you'll see that this sort of AT is used when the balance is being reduced or the state, the storage is being increased. But we don't actually mention it as an invariant here. We could do.